Welcome to today's lightning talk. It's going to be a quick 15-minute session, including some questions. The topic of why segmenting your infrastructure into tiers can potentially make your infrastructure design better. In essence, it's an intentional approach to infrastructure segmentation using infrastructure as code. In what we'll be talking about today, quick introduction to who I am. We'll kind of define the standard way of doing things, which is what I've termed as infrastructure bucketing. I'll then introduce the concept of infrastructure tiering. I'll then also go into a tried and tested approach that we've used and have used in many companies for infrastructure tiering. We'll then summarize what we've spoken about today, and then I'll leave some time for questions. Briefly, who am I? My name is Thameez Bodhanya, originally from South Africa. I'm currently the engineering lead of DevOps and SRE at Forward Earth. Forward Earth is a carbon management company. If you want more information on that, please reach out. My team is hiring. I don't have much social media, but I do have LinkedIn. You're welcome to reach out to me there. So just to speak about what I've termed as infrastructure bucketing. Infrastructure bucketing, in essence, is what most of us do anyway when we create infrastructure using infrastructure as code, be that Terraform with stacks, Terraform with workspaces, Pulumi with stacks, CDK with stacks, or other tools. We create these logical collections of related infrastructure, and we put them into what I've termed buckets. These generally come up organic for most companies, and I found they kind of fall into two buckets. Either one large workspace or stack called infrastructure, and everything is thrown in there, or these micro stacks of app 1, app 2, or other logically related things, but not fully intentional in the grand scheme of your infrastructure as a whole. So just as a diagram with some positives and negatives. So in a single workspace, cool, everything's together. That means if I need to reference output from this piece of infrastructure for this guy, it's there. Everybody knows where to go. Potentially they have good names in files that are in a single location. Deployment is fairly like CDK deploy or Terraform apply. Very simple to do, difficult to manage at scale. High blast radius of change, and that's one of the major downsides with things being in a single workspace, is deployment time takes forever, especially if you're using Terraform with large accounts or multiple accounts. And you make a change here, or someone does Terraform destroy while you've lost your environment. Potentially all of your environments if you're doing very poor management between your tiers. Numerous workspaces, well, you get rid of that dependency on a single blast radius, but now you've got multiple deployments, you have fuzzy dependencies between them, complex coupling patterns, and one of the most problematic things, in my opinion, is the first point here, is fuzzy dependencies. You aren't sure whether workspace A depends on workspace B. The outputs and inputs are very unclear. If you're using Terraform, you're just referencing the space. If you're using CDK, you're potentially just using a CloudFormation output. So that's problematic in my opinion. And I've dealt with this in many companies, and the approach that I've taken and the approach that I'm trying to propose today is the concept of what I call infrastructure tiering. Tiering, where it differs from bucketing, in essence, is an intentional approach to bucketing. It's thinking out your buckets in advance and putting them, as the word defines, tiers, where each tier builds upon the previous tier. This is not a revolutionary new design. I'm not pitching it as, hey, I created this. This is a common approach to many things, including code bases as whole, but we don't seem to apply it in infrastructure commonly. So 3 points that I would say makes a tier different from a bucket. The first is that each tier is defined as a single workspace or stack. It's isolated. And the interactions between the tiers are explicit between flat input and output variables. So what are flat input and output variables? That means, if we use Terraform as an example here, is your output in Terraform should not be an entire module. Your output in Terraform should be the value that's required in the next tier. So that should be, for example, a VPC ID, a subnet ID, a IAM role ARN. It shouldn't be the entire IAM role module, for example. What the next tier needs should be clearly defined in what the previous tier defines in their output. That's flat outputs. The next one is that each tier, related to the previous point, takes in a set of inputs, potentially from the previous tier, creates resources, and produces outputs, which are then subsequently consumed by the next tier. So again, you're building up a stack. Finally, and one of the most important points in my opinion, is that each tier has a distinct owner, and this owner is responsible not just for the infrastructure that's defined in, but also with maintaining it, upgrading it, the providers, and all of that fun stuff. So kind of makes sense, right? But when I'm going to present the tiers in a second. When we look at tier number 2, which is what I've defined as your app developer tier, if your app developers want the RDS database or Google Compute database in a SQL database in their tier, that means they're now in charge of maintaining that database. They're now in charge of upgrading that database. They're now in charge of, backups for that database. So that's where the idea of what belongs in what tier has to take into account the concept and the context of your company, the level of your company, the level of your developer's responsibility for the infrastructure, and other contexts that may be important. So this is a high-level overview of what I term a successful infrastructure design. I'm not saying it's perfect. I'm not saying it's the only version of it, but it's what worked in the past and is what worked at many companies for me, both at the startup scale and at enterprise scale. It, in essence, consists of 3 tiers, with the last tier is sub-tiers, if you will call it that. Tier 0, classic data center resources, your foundation aspect of things. Think like VPCs, subnets, perhaps DNS routes, things that really don't ever change, the lowest amount of touch. It's like you create it once and it's probably never going to be touched again. You want to remove that from the blast radius immediately. You don't want anybody to be able to delete your VPC. Right? You don't want anybody to be editing your IP networks within your VPC. So that's kind of tier 0, usually owned by maybe a platform team, your SRE team, your DevOps team, et cetera, et cetera. Tier 1. Tier 1 is what I term your classical infrastructure resources. So you've kind of defined your data center. Now you're building within your data center. That could be VMs, instant templates. It could be your Kubernetes clusters. It could be your databases. It could be S3 buckets. These tiers and what is contained within the tiers, again, is contextual to your company and your company's needs and the level of ownership. If your application developers need a crack ton of S3 buckets, then perhaps it shouldn't be in tier 1. Perhaps they should be the owners of it in tier 2. But if you're in a high secure environment where S3 buckets need to be, every S3 bucket that's created needs to be signed off by security, perhaps that should live in tier 1. Perhaps that should be the ownership of the platform or security team. So that was tier 1, classic infrastructure resources. I'll explain more about each tier in a second in depth, but just at a high level. Tier 2 is what I call your application resources. These belong to your specific applications. These could be domain level, these could be team level, whatever it may be. But your teams, what is highest of touch, what is being changed consistently, what they need ownership of, that should belong in tier 2. And as we see, tier 2 depends on tier 1 depends on tier 0. If you attended my talk yesterday, you would have seen I used a Kubernetes cluster in my example, in my demo. The Kubernetes cluster took me about 7 minutes to deploy with everything I needed because that was a tier 1 resource. All it needed was a VPC ID, some subnets, and DNS for our creation of it. And that created a production level Kubernetes cluster with all my charts, everything deployed to it in 7 minutes. That means in a disaster recovery scenario, I could be up and running in about 7 minutes, provided I give it some outputs. The same thing for tier 2. If I need to shift tier 2 from cluster A to cluster B, it just needs a cluster ID, or perhaps it depends on your cloud provider, but I mean, it needs its outputs, it needs its inputs, which are clearly defined, and you can just throw that across to another tier. So to speak a bit more about the actual tiers, to go a bit more in depth and give you some examples of what may live in each tier. Again, what lives in each tier is up to your company, your context, but this could give you an idea. So again, it's a foundational level. It's shared by all subsequent tiers. Generally, I would say your network infrastructure should live there, your connectivity, perhaps security. It depends on your security architecture. Your IAM roles may be defined here, and other tiers can then subsequently assume those roles. Perhaps your application needs to create roles. Again, it depends on your context of your company. Tier 1 is the shared platform. It's your classic infrastructure resources. So container orchestration tools like EKS clusters and the add-ons related to the EKS cluster, or EKS here, just AWS. Again, it's applicable to all things. Your observability tooling, Prometheus and Grafana if you're in Kubernetes, but this could be other things as well. Security toolings, again, this is just some examples. And compute resources. So here it's interesting. You could define your launch templates, you could define your AMIs, you could define your node groups, or you could actually define the actual compute resources here, like the actual virtual machines. It depends, again, on your company context, security context, and level of ownership within your developers. Tier 2, is your general application resources. These could be RDS databases. These could be KMS keys. Again, it depends on where your level of ownership within your company is. You may want to shift certain resources from tier 2 to tier 1 to tier 2. I would say tier 0 is generally your most defined tier. Tier 1 and 2 are the most fuzzy depending on your company's context, but that's where you take the intention. That's where you take a minute to step back before you just create some new infrastructure and think, okay, how high of a touch is this? How important is it that it breaks? How shared is this? How many other workspaces or tiers are going to depend on this? And then based on that knowledge, you decide whether it should be tier 1 or tier 2 at least. Skip that one. So in summary, I'm going to leave a lot of time for questions because I'm assuming there may be questions. If there's not any other questions, I can go a bit more in depth. But in summary, we already use infrastructure as code. Many of us use infrastructure as code. Infrastructure of code has a great side effect of already bucketing infrastructure resources. My idea is to bucket with intention. Don't just bucket for the sake of bucketing. Don't just bucket because we think this database should be used by this service, and then 3 months later you realize that that service is also using it, that service is also using it, et cetera, et cetera. I've worked at a company where the VPC was defined in the backend stack, and that caused a lot of problems when that version of the backend was deprecated for something else entirely. And to strip out that VPC and everything else that depended on it was painful. Tiering infrastructure has some positive gains. As I said, it reduces the blast radius on change because if you just remove a tier 2 thing, that just impacts that application itself. It reduces the time of deployment because lower touch things that don't ever change don't need to be deployed, and so they aren't part of the deployment process. Your workspaces are smaller, they're more scoped. You have clear ownership, so if something needs to change in that tier, if something needs to change in that workspace, you know who to go to, someone who has ultimate say within that. There's clear dependencies between the tiers, specifically if you're using flat inputs and outputs. And yeah, increasing flexibility is one of the major things. So tier 2 belongs to the application developers. The platform team, the SRE team, doesn't need to review that. They can review it, but they shouldn't need to review it. And yeah, tier according to your context. What I've presented here today is just an approach that has worked. As I said, tier 1 and tier 2 are fuzzy. They can change depending on your company context, your security profile, your company's needs, et cetera, et cetera. An example has been noted here, like KMS keys, RDS databases, et cetera, et cetera. And yeah, remember that tiering always means building upon the previous level. What does that mean in certain cases? It may mean that a tier 2 resource requires the VPC ID. Your tier 2 should never have a direct call out to your tier 0. If that VPC ID is needed in any subsequent tiers, it needs to be passed from tier 0 to tier 1, and then the subsequent ones then consume it. Cool, I have the 2 minutes ahead of me. Any questions at this point? Yes? Yeah, so just to repeat the question for those streaming, the question is that do infrastructure as code tools allow for this idea of dependencies between the tiers? Is that correct? Yes, it does. Terraform allows you to import state from other workspaces, and that's one of the approaches that we've used to pass outputs and inputs between them, especially if you're using flat outputs and flat inputs as I've prescribed. It's very easy to do. You import the previous tier's state into your workspace, and then it's state.outputs the output that you're looking for. You could also use other key value things like SSM store or any key value system to be able to pass inputs and outputs between the tiers. Any other questions at this point? Cool. Then thank you for your time. Thank you for listening today. The slides will be online, and if you want to reach out and chat at any point, please contact me on LinkedIn. Thank you.